warmest, do you hear me? Our warmest congratulations to the whole group of people and organizers for organizing this very essential and excellent conference and this excellent exhibition. And thank you very much for hosting us here. So we will, our presentation will be about the innovative bioclimatic European school in Crete and its holistic philosophy beyond the natural materials.
So this project is the first prize of an international competition that our office won back in 2012. The competition was organized by the United International Architects and the organization for the Greek Organization for School Buildings. We started as a team of 11 people working for this competition.
And for the detailed design stage, worked until now more than 30 people cooperating with each other.
The site where the European school will be built is outside of Heraklion in the area of Voutes.
It is an olive grove of 15,750 square meters next to the university.
The school will be built for 780 pupils. It consists of 3 separate schools with their respective entrances and their courtyards. The 3 schools are about 7,600 square meters.
The school design aims to embrace pupils and promote social interaction while harmoniously connecting with nature. Designed with a holistic approach, the building complex applies all aspects of passive low-energy ecological design and incorporates principles of ancient and vernacular local architecture.
Humans need direct contact with Earth and nature in order to remain healthy. Thus, the scale of the building is small and in relation to its environment. Natural materials enhance this experience. Most classrooms are designed or are on the ground floor and with immediate contact to Earth.
The architectural design is based on a sequence of courtyards which is used in the Mediterranean for thousands of years.
The courtyards, with their natural environment, are lungs for activities and promote a sustainable society.
Natural cooling in the summer and thermal comfort in the winter is achieved within the courtyards.
The building consumes the least possible energy due to its bioclimatic design principles. Using regional resources and low-embodied energy materials, a healthy environment is achieved. The building's latent breathing is ensured, and any moisture of the indoor air is released.
Here you see a simulation with indicative results of a schoolroom on an indicative week of January, showing that during the sunny days, heating is not necessary.
And here for the arts room, again, indicative annual results of dynamic thermal simulations with the heating requirements. There's a consumption of 1 kilowatt hours per square meter, and there is no need for cooling.
The largest side of the buildings is 100% south-facing in order to achieve maximum thermal gains in the winter and ensure an easy sun protection in the summer.
Passive thermal gains are achieved through southern glass facades or southern skylights.
Thermal gains are achieved through winter gardens as well.
An additional passive thermal system is the thermal wall. Where there are no arcades on the southern facades, Trombe walls have been designed.
Trombe walls consist of earthen blocks in this special class room interior and have openings in their lower and upper zone.
We're utilizing mainly the night temperatures and additionally the earth temperature. Natural cooling is achieved by shading the elevations with timber arcades and their green roofs or timber blinds.
Green walls, wooden pergolas, trees and vegetation protect western and eastern elevations.
The natural cooling is achieved through vertical ventilation in the buildings. Each room has skylights very low in the north and at the highest points in the south, and this creates the stack effect.
Furthermore, timber shelters with green roofs protect and offer places for outdoor activities.
There is ample natural lighting, which is achieved everywhere due to the small width of all the buildings. The walls of the kindergarten classroom, where you can see here, are coated with earth plaster. The roof and the floor are of timber.
Timber reflectors in the southern part of all classrooms and halls, here as well, provide diffusion of light and visual comfort to facilitate work.
Thermal comfort is achieved through good insulation and thermal mass in the building.
Earthen blocks inside buildings help to maintain a cool environment in the summer and heat in the winter.
There is exploitation of the excavated earth of the sites, which will be utilized.
Here you see images from the excavation process and the geotechnical research. 5 samples of earth were tested. The soil material from the excavation of the field is received by a depth of 30 to 40 centimeters from the surface. A drying, grinding, screening process follows. Drying is carried out in hot air dryers.
A laboratory test have followed.
A number.
Several of them.
Of tests. For example, flexural strength test, compressive strength test, deformation behavior under load, shrink age test, initial shear strength test, moisture behavior, resistance to abrasion, etc.
Inside the buildings, earth is used for non-bearing walls as a material with extremely high thermal mass. The excavated soil was analyzed by the specialized certified building material laboratory of the Aristotle University of Thessaloniki in the School of Civil Engineering by Professor Ioanna Papagianni. All necessary laboratory tests were carried out for the preparation of stabilized earthen blocks as well as the manufacturing instructions.
Earth plaster in its natural color on the left and added natural colors on the right in a primary school class.
Here you can see the earthen blocks inside the kindergarten hall.
And earthen blocks in the kindergarten dining area. Wooden partition, a wooden floor and wooden furniture.
Here you can see in the section the earthen blocks in the kindergarten dining area and the timber construction of the roof and the green roof on top.
Earthen blocks will have the size of 29 by 14.5 by 9 centimeters. The filling at the perimeter walls of the buildings will have 30 centimeter thickness. Υπερβατική οπτοπληθοδομία, I don't know exactly how it is called in English. The interior walls will be 14.5 centimeter thick, constructed as running walls, δρομικοί. Where concrete and earthen blocks come in contact, timber elements will be applied, as you see here. The horizontal rings, sanas, here will be timber as well. Earthen blocks will be visible in most interiors, and in some parts will be coated with earth plaster. The bonding mortar will be earthen as well.
Metal molds with 1 centimeter wall thickness, you can see here on the left, were used by the laboratory tests for achieving compaction. A special press was used having a compression strength of 300 kilonewtons and no vibration. After compression, the earthen blocks are transported to a maturing area where their stamina develops. In this area, they should not be exposed to dry air because the rapid evaporation of water will lead to cracking. The recommended room temperature is about 20 degrees Celsius and relative humidity about 65. Percentage, yeah. Endurance grows with age. A significant percentage of endurance is achieved after a month from the production.
Earthen blocks will be manufactured, hopefully, in a local industry, which has the required machines for the production of concrete blocks or similar building materials. One of our aims is the industrial manufacture of earthen blocks and earth plaster and earth mortar. Industrial products can be tested and certified. A further aspect for the industrialized manufacture is the dissemination. It is important to encourage the manufacturers of sustainable energy-saving and health-promoting products. Earth blocks have similar procedures with bricks. Earth plaster and earth mortar is applied with traditional techniques. Earth blocks, as in fill of no load bearing walls, can be easily adapted on a frame construction. Timber would be the ideal, of course.
Industries and manufacturers in Heraklion, Kozani, Kilkis, and other parts of Greece are interested in producing earthen blocks and plaster. They already have made experimental productions and they search for ways to improve them. We came in contact and cooperated with manufacturers who carried tests for the industrial production of earthen blocks for this school project. The tests will be completed with the finishing of the detailed design stage. The development of a Greek earth building code or Greek national standards for earthen building materials is absolutely necessary in order to have a formal guide for the private and the public sector. In Germany, since the introduction of the air building rules, earth building has increased noticeably.
From the discussions with the Ministry of Infrastructure and Transport, the Department for Standards and Quality, we had the information that the contracting authority can write the required article about earth blocks and earth materials for the tender documents because it is a public building. The technical description will be then compulsory for the implementation of the construction. For prices and costings of workers, scaffolding, machinery, etc., the Ministry can assist. There is a law since 2004 that allows the contracting authority to write articles and specify construction methods for public buildings.
By using earth from the excavation for earthen blocks, we bring nature itself in its bare form to the classrooms. Earth is the friendliest building material. It creates a sense of well-being. In terms of thermal mass, as you all know, it's ideal. It regulates internal air humidity by 50%. It absorbs toxic pollutants.
Is low embodied energy material, recyclable. You know all of this, okay. It is available in abundant quantities, no toxicity, and earth allows low-cost construction. In Germany, earth adobes cost, for example, 40% less than fired blocks. And earthen structures' life cycle is unlimited as long as it is protected from moisture and reasonably maintained, as all of you mentioned until now.
The use of materials will be local, natural, and ecological materials. This saves energy, resources, and promotes the local economy, and creates an environment with high-quality indoor air, resulting in wellness for the students.
Importance in this project is given to the recyclability of materials, energy saving during transportation, and low embodied energy. The materials are from renewable sources, biodegradable and non-toxic. This ensures the latent breathing of the building shell so that the humidity of the indoor air will be vented to the outside. Apart from earth, stone is used, a material found in abundance here in Crete, timber, local reeds, and wool.
At the beginning, there was the intention to use Greek sheep wool to support the local economy. But unfortunately, the price was very high, and therefore we decided for the earth wool with the ECOS technology, which its binder is plant-based, and replaced the phenol formaldehyde binder used in glass mineral wool products. Sheep wool will be probably used only as a demo in the kindergarten building, which is the smallest one.
A variety of natural ground materials is used to enhance physical experience. Pressed earth will be used widely.
A further intention was to adopt elements from the local vernacular architecture, such as the stone dome structure of the Mitato, as a resting space for the kindergarten pupils. Structural complications due to the existing legislation, though, prevented that. We gave a different shape to the dome than the traditional one and changed the philosophy of the supporting structure, which is now made of timber frame with stone cladding. Wattle and daub construction will be applied for the interior in between the timber skeleton. The insulation here will be sheep wool.
The inside will be plastered with clay.
All the pitched roofs will be made of laminated timber, as well as the outdoor sheltered spaces. Pergolas and little structures are made of wood. The building structure is made out of reinforced concrete, and this is compulsory due to the nature of the
because of the seismic regulation here in Greece, for public buildings and schools. Materials remain in their bare form to cultivate truthfulness.
We aim the materials to be visible in order to be part of the education, incorporating some truth windows in the walls.
Roofs and many walls are planted with endemic species to improve microclimate. They do not need treatment. Topsoil from the excavation will be used in order to match the surrounding natural environment.
Here you can see a detail of the green roof and its timber structure.
And the earthen blocks here with the insulation outside. The yard's floor will remain as natural as possible with wild grass and soil. There are studies supporting that the soil makes children happier and healthier. The holistic pediatrician Maya Shetford-Klein speaks in her book The Dirt Cure for terrain medicine, with soil treatment of neurological and other chronic problems. Soil also increases the ability to learn.
The contact with soil and nature enhances good mood. This is partly due to a soil bacterium called Mycobacterium vaccae that enters the body through the nose and skin and increases the level of serotonin. It makes us happier and smarter, and up to 3 weeks after its exposure to the earth.
The element of water is a material as well. Rainwater comes visible from the gutters in its downward route and is collected in underground reservoirs. Ponds and small streams give opportunity for natural experiments and improve the microclimate of the courtyards.
Except of its significant means of cooling, water is an important element for life.
So the aim of the school is to act as a prototype for healthy environments in direct connection with nature. With its holistic, sustainable philosophy, it is the best place to activate love for the environment and for life, for the children.
Thank you very much.